Imagine standing on a quiet beach, waves lapping at your feet. Right now, about 10 quadrillion water molecules are hitting your body every second. That's 10 to the power of 15. Well, of course they are. You're surrounded by water. So, let's shift the scene. What about light? Of all the light the sun releases, less than 1 part in 10 to the power of 22 ever reaches you. It's like trying to catch 1 grain of rice from all the rice on Earth thrown into the wind. And yet, that's enough to heat your skin, grow a tree, or ignite an entire planet's atmosphere. We've been told that light from the sun takes 8 minutes to reach Earth. But that's not the whole story. That's just the final stretch. The real journey starts in the sun's core. Not the surface, but the very heart, where it's 15 million degrees Celsius. Here, hydrogen atoms are fused into helium under unimaginable pressure. And in that fusion, photons are born. But they don't shoot outward. They don't travel in straight lines. Instead, they scatter like drunks in a bar fight, in every direction imaginable. Imagine the most crowded mosh pit on Earth. Now, multiply that by 1 billion. That's the sun's core. Plasma is so dense, it's like the universe's version of quicksand. A photon can't move more than 1 millimeter before it's absorbed by another particle, then re-emitted in a random direction. We call it a random walk. And because of this, a single photon takes anywhere between 10,000 and 170,000 years just to escape the sun. That's not a metaphor. That's real. Photons reaching your skin today could have been born before humans developed language. The oldest known written language appeared around 5,000 years ago. Some photons hitting your face today started their journey 20 times before that. And once they finally break free, they accelerate, zooming through the vacuum of space at 300,000 kilometers per second. That part is quick, just 8 minutes from sun to Earth. But compared to the wait, it's like marinating a dish for a week and then torching it in 5 seconds. The entire history of civilization passed, while that one photon tried to get out. Now, think bigger. The sun emits around 10 to the power of 45 photons every second. That's a 1 with 45 zeros. Earth has about 7.5 quintillion grains of sand, 7 followed by 18 zeros. So for every grain of sand on Earth, the sun emits over 1 billion trillion photons every single second. And yet, the fraction that hits you, microscopic, negligible, and still enough to change your biology. Here's the eerie part. Most of those photons never touch anything. They miss every planet, every moon. They just drift for billions of years, never interacting, never noticed. A cathedral of energy built in a cosmic desert. We forget this. The sun is not sending light to Earth. It's vomiting it in all directions. We just happen to be in the way. And every beam of light you feel wasn't meant for you. It just found you. Let's get microscopic. What is a photon? A photon is a quantum of the electromagnetic field. It has no mass, no charge. It always travels at light speed. There's no such thing as a slow photon. And bizarrely, it doesn't age. From the photon's point of view, if it could have one, its entire existence is instantaneous. Emission to absorption, 0 time. It could have traveled for 13 billion years. And yet, to it, no time has passed. We discovered the photon less than 120 years ago. Albert Einstein, in 1905, explained the photoelectric effect, that when light hits a metal, it can eject electrons. But the math only worked if light came in discrete packets, what we now call photons. That discovery? It's what won him the Nobel Prize. Not relativity, not E equals mc squared, but the photon. And today, we use that same principle to make solar panels, to see inside the body, to scan groceries, all from understanding that light isn't just a wave. It's a particle, sometimes both, sometimes neither. Back to Earth. The photons we do catch don't show us the world directly. They bounce off trees, off skin, off books. They reflect into your retina, strike opsins inside your eyes, and get converted into neural signals. We don't see objects. We see what light was doing a fraction of a second ago. And in some cases, much longer ago. Look at the stars. Starlight from Sirius takes 9 years to reach us. Betelgeuse? Over 600. The Andromeda Galaxy? 2.5 million years. That means every time you stargaze, you're looking at ghosts. Dead light from distant pasts. Not all light is visible. The human eye detects wavelengths between 400 and 700 nanometers. That's just a sliver of the full spectrum. Infrared, ultraviolet, gamma rays, all photons, just different energies. Gamma photons are created in supernovae and nuclear explosions. They're so energetic, they can pass through lead. Radio photons, on the other end, are kilometers long. That's what your phone and Wi-Fi use. We live in a soup of invisible light, streaming around and through us. All the time. We just evolved to ignore most of it. Here's a twist. Photons have momentum, even without mass, which means sunlight, if intense enough, can push things. We call it radiation pressure, and we've used it to sail spacecraft, literally, on beams of light. Japan's Ikaros probe, it used a solar sail to navigate space using nothing but photon pressure. No fuel, just the push of ancient starlight. Even comets grow tails because of this. Photons hitting them push dust away. That's what forms the glowing streak. Light has no mass, but it still moves worlds. So what about the photons that die in fire? When a nuclear bomb detonates, it releases a flood of photons in the first fraction of a second. Millions of joules of light. Blinding. Us don't. But here's what no one thinks about. Those photons were born inside the sun. 100,000 years ago. They took millennia to escape the sun's core. And now they end, suddenly, in fire. A photon's final moment doesn't always match its age. We think of light as simple, but it carries secrets. It encodes temperature, motion, distance, composition. Astronomers read starlight like a fingerprint. Every black line in a spectrum, a missing wavelength absorbed by some element. That's how we know what stars are made of, what planets might have atmospheres, what galaxies are doing billions of light years away. We don't touch those places. We don't hear them. We read their light, like a story sent across time. So tomorrow, when you step outside and sunlight brushes your face, remember, that warmth started in a fusion furnace tens of thousands of years ago. It wandered in atomic chaos for most of human history, then crossed space in minutes, and finally found you. And all it ever wanted was to be noticed,